Okay, welcome to lesson 1, part 2. So if you haven't already, please make sure you've watched the first part of lesson 1. We're picking up where we left off on the same PowerPoint, and we will also be taking a look at some homework examples near the end of this video. All right, so the next thing we're looking at is changing mixed numbers to improper fractions, and we'll also be changing improper to mixed numbers as well. All right, so here are the basic steps. Multiply your denominator times the whole number and then add the numerator. And we're going to make sure to keep the same denominator. So our example is 2 3/4 becomes 11/4. And what this arrow is meant to demonstrate is what we're doing is we're multiplying 2 times 4, which is 8, and then adding 3 to get 11. So that's where that numerator comes from. And then that denominator of 4 stays the same. Okay, so let's take a look at one more example here. Change the mixed number to an improper fraction. And our example is 5 2/7. And so what we're going to do is multiply 5 times 7, which is 35. And then we'll add that numerator of 2. And that will be 37 for our numerator. So again, we multiplied the denominator times the whole number and then added the numerator. 5 times 7 is 35, plus 2 is 37. Don't forget to keep that same denominator. In this case, it's 7. So 5 2/7 gets changed to 37/7 as an improper fraction. And by the way, I guess I should just remind you what these things actually are. A mixed number, it's sort of a mixture of a whole number and a fraction, such as 2 3/4 or 5 2/7. An improper fraction, that's defined as a fraction where the numerator is larger than the denominator. So it's a fraction that's more than one whole. All right, let's take a look at how to change the other way. So changing improper fractions back to mixed numbers. Instead of multiplying, this time we divide. So we divide the numerator by the denominator. Most of the time there will be a remainder. So the quotient, the answer, that's the whole number. And then the remainder goes over the divisor in the fraction. So here's a quick example, 8/5. That means we're doing 8 divided by 5. So we want to know how many times does 5 go into 8. So it goes in one time because 5 times 1 is 5 and 5 times 2 would be 10. That'd be too much, right? So 5 goes into 8 one time. If we do 1 times 5 and get 5, let me add a little bit more to this here. 1 times 5 is 5, then subtract from 8 and we get 3. That's our remainder. So in our final answer, we write 1 and 3/5. So notice the 1, that's the quotient. That's the answer, that becomes the whole number. The remainder, that goes in the numerator of the fraction here, and then your denominator still stays the same. So that denominator of 5 is still there. So 8/5 is the same thing as 1 and 3/5. You can also check by multiplying like we did previously, right? So multiplying 5 times 1 and then add the 3. 5 times 1 is 5 plus 3 is 8, right? So we get back to that original numerator. Okay, and then over 5, of course. Let's do another example. So change the improper fraction to a mixed number. This time we're doing 23/8. So I'm going to set that up as a division problem, 23 divided by 8. How many times does 8 go into 23? Well, 8 times 1 equals 8. 8 times 2, that's 16. 8 times 3 is 24. That's too big, right? So it doesn't go in 3 times, it goes in 2 times. So we'll say 2 for our numerator here, or for our answer, excuse me. 8 goes into 23 2 times. Then we multiply. 2 times 8 is 16. So I'll subtract. 23 minus 16 is 7. So putting it all together in our final answer, as a mixed number, we would write 2 for the whole number. And then for the fraction, we'll put the remainder over the divisor. So 7/8. Okay, so 23/8 changes to 2 7/8 for our final answer as a mixed number. Okay, so we'll need to be able to go back and forth like this when we're dealing with problems involving mixed numbers. Sometimes we need to change them to improper in order to multiply or divide, and then we'll need to change them back for the final answer, which brings us to our next problem. So our next example, this is a division problem, but we start it the same way, whether we're multiplying or dividing mixed numbers. So to multiply or divide mixed numbers, we definitely need to change them to improper fractions first. Okay, so that's what we're going to do for this problem. So we're dividing, and then we are going to be writing the final answer as a mixed number. So we're going to be going back and forth here. Here's the original problem, 6 3/5 divided by 5 1/4. So let's change our mixed numbers to improper fractions first. 6 3/5. So we're going to do 6 times 5 is 30, plus 3 is 33. So 33/5 divided by, now let's change the next one into an improper fraction, 5 1/4. So we'll do 4 times 5 is 20, plus 1 is 21, and we'll keep the same denominator. Okay, so 6 3/5 changed to 33/5, and then 5 1/4, that changed to 21/4. So now we have 33/5 divided by 21/4. Now in our previous video, we did talk about how to divide fractions, so we're going to do that now. Essentially, we're going to keep, change, flip, right? So we'll keep the 33/5 as it is. We'll change division to multiplication. And then we'll flip that second fraction, 21/4. That will become 4 over 21. Okay, I'm going to rewrite it over on the right side just to give myself some more space. So keep, change, flip, 33/5 times 4 over 21. Okay, now we're going to multiply straight across and reduce if possible. Now these numbers look just a little bit big to me, so I'm going to try to reduce now rather than waiting till later. 33 times 4, that's not something I can do in my head. I'd have to write it out. Let's see if we can reduce before I write out that slightly larger answer. Now, I can't reduce 33/5 and I can't reduce 4 over 21, but if we sort of look diagonally, the 33 and the 21, they have a common factor of 3. So I can reduce by 3 for both of those. 33 divided by 3 is 11, and then 21 divided by 3 is 7. Now I can multiply across, and it will be slightly smaller. Let's see, instead of doing 33 times 4, let's do 11 times 4, and that's going to be 44 for the numerator. And then for our denominator, instead of doing 5 times 21, since we reduce, now it's 5 times 7. 5 times 7 is 35. Okay, so it looks like I multiplied across, I reduced by 3 as I was doing that, and now we got 44 over 35. This is still improper right now, which sometimes is okay. But our directions here did ask us to write the final answer as a mixed number. And generally, if your problem starts with mixed numbers, you're going to want the final answer to also be a mixed number. So let's change it. Let's change it by dividing. So let's divide 44 divided by 35. So I'm doing the numerator divided by the denominator. All right, how many times does 35 go into 44? Thankfully, just once. 35 times 2 would be 70. That would be too big. So 35 times 1, that's 35. And let's subtract it from 44. And we're getting 9. So it looks like it goes in once with a remainder of 9. So we'll write our final answer as a mixed number of 1 and 9 over 35. And that's our final answer as a mixed number. Okay, good. So just to summarize what just happened in this problem, dividing mixed numbers, the same thing for multiplying mixed numbers. We change them to improper fractions first. Then, because this was a division problem, we did keep, change, flip. We changed division to multiplication, and we multiplied by the reciprocal of the second fraction. So we flipped the 21 over 4 into 4 over 21. And then we multiplied across, we reduced, we got 44 over 35, and then finally we changed that to a mixed number by dividing. Now just a quick note, if you didn't reduce, let's say you did actually just multiply across and do 33 times 4. Let's see, I have to write that out. It would be okay. It would just be a little harder, I think, because the numbers get bigger. So that would be 132 over, and then 5 times 21. That's going to be 105. See, now I'd have to reduce that. That's even harder now. Apparently, I could still reduce it by 3. That would be a little bit more difficult for me to know that. Anyway, I hope this is maybe convincing you that it's a good idea to reduce earlier, because if you save it till later, it's definitely harder. Yeah, so I might not even realize that I can reduce. Maybe here, let's do this. If you didn't realize that you could reduce, let's see what would happen. And maybe let's see what would happen if we just changed it to a mixed number right here. So 132 divided by 105 goes in one time. We would subtract. So we would get, let's see, 1 and 27 over 105. Okay, and then from here, we would want to try to reduce. 27 is 3 times 9. I might try to divide by 3 here. 27 divided by 3 is 9. 105 divided by 3, I'd have to write that out. And apparently it's 35. Anyway, okay. Let's see, 105 divided by 3. 10 divided by 3 is 3 with the remainder of 1. Bring down the 5, then I'm getting 5. Anyway, what I'm working out here is just dividing 105 by 3 and getting 35. Okay, so what I was just showing the past minute or so is just, here's another way you could get to the answer by reducing later on. But as you can see, it involved much more work and dealing with bigger numbers, and it's less likely that you'd even realize that you could reduce. So once again, it's probably better if you reduce earlier. It was good that we reduced with the 33 and the 21 earlier on in the problem. Alrighty, let's move on to the next problem. So the last 2 examples in our notes here deal with mixed numbers again, but we're going to be adding and subtracting. Okay, for these problems, you don't necessarily need to change them to improper, although you could. But what we're going to do is actually line them up vertically. So that's what this first sentence says. First, line up the mixed numbers vertically. And then notice mixed number answers should not include improper fractions. Okay, so here's what we mean by lining them up vertically. You basically just rewrite the problem. 3 2/5 plus, see how I'm going to stack them up. I'm going to put this 4 as the whole number right under the 3 whole number, and then the 11/15 gets lined up under the 2/5. So you're kind of lining up the whole numbers and lining up the fractions. Okay, now the real work comes in with adding the fractions. So when we do it this way, we pretty much get to just focus on the fractions separately. So let's work on adding 2/5 plus 11/15. Now we need a common denominator here. Since 5 goes into 15, we can use our least common denominator can be 15. So to change the 5 to a 15, we would do 5 times 3. So 5 times 3 is 15. We need to do the same thing to the numerator. 2 times 3, that's going to become 6/15 for my fraction. And we'll add that with the 11/15. So 6/15 plus 11/15, that becomes 17/15. And then we can add those whole numbers. 3 plus 4 is 7. Okay, so let's just pause here for a moment. We did 3 2/5. We changed that to 3 6/15. We added that with 4 11/15, and we're getting 7 17/15. This is actually not the final answer, because 17/15, that's technically improper, and we don't want to have an improper fraction within a mixed number. So here's what we need to do. There's technically kind of a whole number 1 almost hidden in that fraction. A similar example would be if you're adding, I know we're not talking about decimals yet, but let's say you're adding decimals. Here, I'll put some dollar signs in front of it. Let's say you're adding $3.60 plus, I don't know, $4.80. You wouldn't say that that's $7.140, right? That doesn't make any sense. We would add, and we would actually need to carry the 1, right? There's an extra dollar in there. So we're going to be doing something similar with fractions. Let me finish up my decimal example. So if I add, let's see, oops. If I add straight down, 0 plus 0 is 0, 6 plus 8 is 14. We just sort of instinctively know, okay, we carry the 1. Well, the carrying the 1 is sort of, you're adding something to this other decimal place. We kind of need to do the same thing with the fractions. There's a whole number 1 that we're going to need to add. Okay, so in my example, even though I started with $3 and $4, I don't end up with $7, I end up with $8 because I had this extra dollar. For our problem here, the 7 and 17/15, it's really going to turn into 8 and then some left over. So let's figure out where that 8 actually comes from. The 17/15, that's an improper fraction. If we change that to a mixed number, it would actually be 1 and 2/15. So just off to the side, I'll just write that out, 17/15. If I write it as a division problem, 15 goes into 17 one time with a remainder of 2. So that's where the 1 and 2/15 comes from. Okay, and then the 1, it's almost like we can carry that. We can add that with the 7. Okay, so the 7 plus 1, that's where the 8 comes from. And then the 2/15 is our fraction. So that's our true final answer here. So 8 and 2/15 is our mixed number answer. Now, it's very possible you felt confused by all of that, which is fine. Here's another way to do it. I'm just going to warn you, this other way involves, it's going to involve some bigger numbers, but it won't involve the confusing carrying the 1 process. So here's another way to do it. I'm going to clear the writing that I've done on this slide here and do the problem again, just to show you that you have options here. Okay, so let's say you wanted to do it a different way. Let's say you wanted to change them to mixed number or change them to improper right away. Okay, so rather than lining them up vertically, let's change them to improper fractions. So 3 and 2/5, 5 times 3 is 15 plus 2, that's going to be 17/5, plus then 4 and 11/15, we multiply and then add. 4 times 15 is 60 plus 11, that's 71/15. Okay, so 71 is a slightly bigger number. It's not that bad. Sometimes doing it this way, you can really get to some very large numbers. But here's what we have, 17/5 plus 71/15. Still, we would need a common denominator, an LCD of 15. 5 times 3 is 15, so we'll do 17 times 3, which I need to write out. And that's going to be 51. So it looks like we're getting 51 over 15 plus 71 over 15. Okay, so we have the common denominator of 15. We add the numerators, 51 plus 71. That's going to be 122. So we're getting an improper fraction of 122 over 15. Now we should change that back to a mixed number. And we'll do that by dividing. 122 divided by 15. Okay, so how many times does 15 go into 1? It doesn't. 12, it doesn't. So I just basically need to figure out how many times does 15 go into 122. So that might take a bit of work. Let's see. Let's try 5. Oh, nope. Just kidding. Okay, 5 is too small. Looks like I was going to try 7. That's 105, getting closer. Let's try 8. 120, yeah, there it is. Okay, so see how close that is to 122. Okay, so the work I just did was trying to figure out how many times does 15 go into 122. It looks like it's 8 times. So I'm going to write 8 above my division problem here for the quotient. All right, 8. And then 8 times 15 is 120. And then there's our remainder of 2. So our answer is 8 and 2/15. So you just saw that problem done twice. You can decide which method you prefer, which method seems easier or more efficient, whatever, whatever you think is best. Either one of those is fine. I will warn you that when you view the examples on the homework, you'll see it done the first way, lining up the numbers vertically, but this way is totally fine as well. All right, let's do one more problem here. This is a subtraction problem. I'm also going to show this one two ways as well. So the first way is the way you'll see it in the examples and on your homework as well, which is borrowing. Okay, so sometimes what you can do is line up the numbers vertically, just like we did before, but with subtraction, sometimes we need to borrow. So let's see what happens there. Before I do that, I'm going to right away just go ahead and get a common denominator. So let's see. I can see our fractions have a denominator of 4 and 6. So I can use a common denominator of 4 times 6, 24, or I can actually use 12. So 12 is a multiple of 4 and a multiple of 6. So let's go ahead and change those fractions to have a common denominator of 12. All right, so 4 times 3 is 12. So I need to do 1 times 3. So that's going to be 3/12 for that first fraction. So 12 and 3/12. And then for the second one, let's see, 6 times 2 is 12. So I'll do 5 times 2 is 10. So that's going to be 8 and 10/12. Okay, so I rewrote it with a common denominator, but now what we're going to do is line them up vertically. So 12 and 3/12 minus 8 and 10/12. So just like the last problem, I'm going to line up the fractions and then line up the whole numbers. Okay, and now hopefully what you're noticing is if we try to subtract 3/12 minus 10/12, that's technically a negative number. We are not dealing with negatives quite yet. In this original problem, 12 minus 8, it's definitely going to be something positive. So if you run into this situation, what we're going to do is borrow. Okay, so borrowing is hopefully something that you're used to doing with regular whole numbers. It's just that it's a little different with fractions. So what I'm going to do is borrow from this whole number 12 and write 11. So I'm borrowing a 1. Here's what I'm not going to do though. I'm not just going to stick a little 1 next to the 3 here and make it a 13. I'm going to write a big whole number 1. Okay, so that whole number 1 kind of, it's like it's been borrowed or taken away from the 12, and now it's going to be joined with the fraction. So this 1 is now sort of creating this mixed number, 1 and 3/12. What we're going to do next is change that mixed number into an improper fraction. So let's rewrite this yet again. This time it will be 11, but then instead of 1 and 3/12, let's change that to an improper fraction by doing 12 times 1, which is 12, plus 3 is 15. So I'm writing 11 and 15/12 minus 8 and 10/12. Okay, so I know it looks strange in the middle of the problem like that. We did create an improper fraction within a mixed number. We would never leave this as a final answer, but what this is allowing us to do is subtract. Okay, so the hard part is over. Now we get to subtract. 15 minus 10, that is something we can do and get a positive number. So 15/12 minus 10/12 is 5/12. And then 11 minus 8 is 3. So our final answer for this problem is 3 and 5/12. So once again, here's what happened. We got a common denominator of 12. So we rewrote this as 12 and 3/12 minus 8 and 10/12. Because 3 minus 10 would have given us a negative number, we had to borrow. So we borrowed a 1 from the whole number 12. We borrowed a 1 and made it 11. The 1 then got kind of stuck with the fraction, 1 and 3/12. We changed that to an improper fraction of 15/12. So we rewrote it as 11 and 15/12 minus 8 and 10/12. Finally, we subtracted and got 3 and 5/12. This is a tricky concept. This might be something that you're not as familiar with. If that's the case, that's okay. If you are not comfortable borrowing and you would like to see another way to do it, I'm going to show this problem one more time. And this time, what we're going to do, just like the last one, is let's change these fractions to improper and then subtract. And you can decide which method you prefer. Just like last time, though, it's going to involve some bigger numbers if we do it this way. All right, but let's give it a try. Okay, so we don't necessarily need to borrow. Let's change them to improper instead. All right, so 12 and 1/4. Let's see, 4 times 12 is 48, plus 1 is 49. So 49 over 4 minus. Now let's rewrite the other one. 8 times 6 is 48, plus 5 is 53 over 6. So 49/4 minus 53/6. We still need a common denominator, and we can still use 12 as our common denominator. And let's do that. Okay, so 4 times 3 is 12. 49 times 3 is something big that I have to write out. Okay, 9 times 3, 27, carry the 2. 4 times 3, 12, plus 2 is 14. So I'm getting 147 over 12 minus, now we'll do the second fraction, 53/6. We're changing the 6 to a 12, so we're going to multiply by 2, which means we're also doing 53 times 2, which is going to be 106. Okay, so I've rewritten my mixed numbers as improper fractions, 49/4 minus 53/6. Then we're changing them to have a common denominator of 12. 147 over 12 minus 106 over 12. Now we get to subtract, keep the common denominator of 12, and now let's subtract the numerators. 147 minus 106 is 41. So we're getting 41/12. And finally, let's change it back to a mixed number by dividing. 41 divided by 12. Okay, 41 divided by 12. Let's see, 12 goes into 41 3 times. 3 times 12 is 36. And when we subtract 41 minus 36, we get 5. So our final answer is 3 5/12. Okay, so you just saw the same problem done twice. The first time you saw it, we borrowed. And then the second time, what we did is we changed our mixed numbers into improper fractions. We had to get common denominators, we subtracted the numerators, and then because we ended up with an improper fraction, 41/12, we had to do an additional step of changing it back to a mixed number. One of the nice things about borrowing is you don't need to do that changing back and forth. You have to borrow the 1, but you don't need to change back and forth so much, and the numbers aren't quite so big. So keep an open mind about still practicing that method. But just know that it's okay to do it this other way as well. All right, so we've come to the end of our PowerPoint notes for lesson 1. Feel free to stop here and go work on the homework. I'm going to pause the video, and then when I restart it, we'll be looking at a different screen. I'm going to show some examples from the homework. I won't always do this with the lesson videos, but sometimes I will show some examples from your homework just for some more practice and for any additional tips you might need. All right. Okay, so here we are looking at homework number 1. As you can see, there's 24 questions. We're just going to look at a few of them here. So the first few deal with reducing or simplifying fractions. Number 2, and by the way, the numbers I'm seeing will be slightly different from what you see, but the type of problem will be similar. So for my number 2, I'm seeing simplify 16 over 8. Okay, so if I simplify this, I want to show you some things to look out for. Let's say I try to reduce by dividing by 4, let's say. And I would get 4 over 2. And then, let's reduce by 2 again. And then let's get 2 over 1. Here's what happens if I write 2 over 1. It's not going to give me credit, okay? So if you ever see this message that says, although your answer is equal to the correct answer, it is not in the correct form, that often means that you just need to reduce more. So instead of 2 over 1, we need to write just 2. So sometimes your answer might not be a fraction, it'll just be a whole number. So 16 divided by 8 is just 2. So 2. Okay, so that's the first one I wanted to let you know about here. We have a bunch more simplifying problems that I'm going to skip through. Okay, then we get to some multiplying. Then we add. Remember, when you add, you need a common denominator. Okay, here's a slightly harder adding problem. Number 9, 5 over 14 plus 4 over 21. It's a little bit challenging sometimes to find a common denominator. So here's one way to do it for this problem. 5 over 14 plus 4 over 21. The common denominator between 14 and 21. Let's see how we can figure that out. One way to do it is actually make some factor trees and break down the 14 and break down the 21. So 14, that's equal to 2 times 7. 21 is equal to 3 times 7. So your least common denominator, it needs all of these prime factors, but we don't need to repeat that factor of 7. So here's what I can do. I can do 2 times 7 and then times 3. Okay, so 2 times 7 is 14, times 3, that's 42. So 42, see how it has all these factors within it. It has this factor of 2 and this factor of 7. It also has this factor of 3 and this factor of 7. It's just that the 7 is just represented one time. So this is one way of getting this common denominator of 42. Now, another way to do it is to list multiples of each denominator. So multiples of 14, I could do 14 times 1 is 14, 14 times 2 is 28, 14 times 3 is 42, etc. I could do the same thing for 21. 21 times 1 is 21, 21 times 2 is 42, 21 times 3 is 63, etc. And then notice that 42 is that common multiple of both of those numbers. So those are some different methods of coming up with this common denominator of 42. All right. Now let's actually do the problem. Once we realize that the least common denominator is 42 in this problem, how do we actually do it? Okay, so 5 over 14 plus 4 over 21. I'm going to rewrite each fraction with a denominator of 42. Okay, now how do we actually get there? Well, as we just saw a couple seconds ago, 14 times 3 is 42. So I would need to do 5 times 3 in the numerator. So that first fraction, 5 over 14, that becomes 15 over 42. For the second one, 4 over 21, I would do 21 times 2 to get 42. So 4 times 2, that becomes 8. So my second fraction, 4 over 21, becomes 8 over 42. In my opinion, that's the hard part. All that is the hard part of the problem. Now, this is the easier part of just adding. So we keep the common denominator of 42, and then we add the numerators, 15 plus 8, and that's 23. Okay, so my answer would be 23 over 42. Okay, and remember to type your answer as a fraction. There's a couple ways to do that. There's this button kind of in the middle of my toolbar here with the 2 blue squares. I can just click on that and it creates a fraction. Then I can type 23, then use my arrow key to get to the denominator, and then 42. Another way to do it without so much clicking is, here's what you can do. You can just do 23, and then you can type your slash key on your keyboard, and then 42. I like doing it this way. It's just a little bit shorter and not so much clicking. So 23, see how it doesn't look like a fraction yet. Then I'm going to hit my slash key. You can't see it, but that's what I'm doing. And then it just creates a fraction. And then I just type 42. And then I hit enter. Okay, so just a little shortcut for you. All right, then we're doing some adding and subtracting. Then we get to dividing. I'm going to skip ahead to some slightly harder problems. All right, next we're writing mixed numbers as improper fractions, and vice versa, writing fractions as mixed numbers. We went over that earlier in this video. Here's a slightly harder one with a bigger number. This is number 17. Mine is 132 over 21. Okay, let's try this one. 132 over 21. So right away, I need to figure out how many times does 21 go into 132? Not sure. Let's try 5. 21 times 5 is 105. Seems a little far off. Let's try 6. Let's see, 21 times 6, that's 126. That seems good. Okay, so I'm going to write 6 for my quotient here. 6 times 21 is 126. Then I'll subtract, and I'm getting a remainder of 6. So it looks like 6 and 6 over 21 would be my mixed number. Okay, I'm going to warn you, this is not the final answer because we can actually reduce this. But let me type it in and just remind you of the error message you might see. So I'm going to type in 6 and 6 over 21. So to type a mixed number, you can click on the mixed number button here and fill it in. 6, and then arrow, and then 6, arrow again, 21. Or if you want to just type it without clicking, you can type 6 and then a space and then 6/21. Okay, so let me type that. 6 space 6/21. So there's my mixed number. Okay, so it's marking it wrong because we can reduce this. All right, so although your answer is equal to the correct answer, it's not in the correct form. I can reduce the fraction part. Okay, so the 6/21, that can be reduced. 6 and 21 have a common factor of 3. 6 divided by 3 is 2. 21 divided by 3 is 7. So actually the best answer is 6 2/7. Okay, so remember you have more than one choice, or sorry, more than one try on these problems. You actually have 3 tries for each problem as you're entering the answer in. That was my second try that I'm using. If I were to use up and get to a third try, when I click on this button, it would say final check. And if you run out of tries, you can always click similar question. Okay, so here, I'll try to show that in a different example. All right, here's one. Let's say I get it wrong. So number 18, 23 1/3 divided by 1 3/7. Okay, this is not undefined, by the way. Undefined is only if you're dividing by 0, which is not happening. So there's definitely an answer, but let's say I check answer and get it wrong. And then I check answer again. I get it wrong a second time. Now, if I click this button a third time, notice how it says final check. Okay, so the correct answer apparently was 16 1/3, and I chose B. So I got it wrong. I can go to the next question if I want to, or what I can do is just click similar question. And I can even do it after I close that little box here. See how I have this red X? I can still click similar question and try it again. It's just that when I try it again, it's going to give me a new set of numbers. Okay, and this new set of numbers will give me another 3 tries to get a different answer correct here. All right, remember you can also click question help me solve this. That helps you walk through that exact question. That's still not going to give you credit. You'll still not get that green check mark if you do that. So you might do view an example. Okay, and you'll see a similar example. Or you could also click ask my instructor. Oh, it's not available to me. All right, but it's available to you. If you do ask my instructor, you'll see a window that opens up with my email address in it, and you can send me a question that way, and I will write back to your Metro email. So that's another option for you. All right, I'm going to continue though. We did do a division problem with mixed numbers in our notes earlier. So I'm just going to skip ahead and just continue giving you a little preview here of what your assignment will look like. Okay, so the last question I wanted to show you is actually technically 4 questions. Number 24, there's part A, B, C, and D. So notice it's the same 2 mixed numbers every time. It's just different operations every time. So this is a nice kind of comprehensive review question. All right, so let's see if we remember all the steps here. So part A, 1 11/15 times 1 2/5. All right, so if I'm multiplying these mixed numbers, I'm first going to change them to improper. So let's do that first. 15 times 1 is 15 plus 11, that would be 26 over 15 times. And then 1 2/5, that's going to become 7/5 because 5 times 1 is 5 plus 2 is 7. Now I'm going to multiply across. Now this is going to get a little bit big. Unfortunately, I can't reduce this at all. So I'm just going to multiply across. 26 times 7, 42. Let's see. It's going to be 182 over 15 times 5, which is 75. Now the directions say type a whole number or a simplified fraction. It doesn't necessarily ask for a mixed number, so it's probably fine to leave it like this. However, I am going to change it back to a mixed number just in case. Okay, so how many times does 75 go into 182? I think it's just 2 times because 75 times 2 is 150. Okay, so it looks like we're getting 2 32/75. 2 32/75. Okay, let's try that. That's part A, multiplying 2 space 32/75. Okay. Then part B, what are we asked to do next? Looks like we're asked to do addition next. All right, so 1 and 11/15 plus 1 and 2/5. Now let's practice adding by just lining up those numbers. Rather than changing them, let's add them by lining them up. So 1 and 11/15 plus. Now, I know I'm going to need a common denominator, so let's get that right now. So our common denominator can be 15. So I'll do 5 times 3 here for my second fraction to get 15, and then 2 times 3, that would be 6. So 1 and 6/15. So now when I add 1 and 11/15 plus 1 and 6/15, let's add 11 plus 6, that's 17/15. And then 1 plus 1 is 2. Okay, remember this happening before? So now 2 and 17/15, I can't leave that as my final answer because the 17/15 is improper. So let's change that. That becomes 1 and 2/15. If I divide 17 by 15, I get a remainder. I get 1 with a remainder of 2. So 17/15 goes in one time with a remainder of 2. And then I can take that 2 whole number and add it with the 1. So the answer is actually 3 and 2/15. Okay. The other option would have been to change each of these into an improper fraction, then get common denominators and add from there. So there's 2 ways to do it. I'm going to just stick with this way for now. So 3 and 2/15. And I'm going to use my little mixed number button here this time. 3, 2, 15. All right, next part C, we get to divide. Okay, so we still start by changing them into improper fractions. So we did that for part A, 26/15 divided by 7/5. This time, because it's division, keep, change, flip. So we're going to change division to multiplication and then change that second fraction to the reciprocal. So 7/5 becomes 5/7. Okay, so 26/15 times 5/7. Now, this time we actually can reduce. The 5 and the 15 can both be divided by 5. So 5 divided by 5 becomes 1. 15 divided by 5 becomes 3. Now when I multiply across, 26 times 1 is 26. 3 times 7 is 21. Okay, and then because this is improper, I can choose to change it to a mixed number. So we'll do that. 26 divided by 21, it goes in one time. 21 times 1 is 21 with a remainder of 5. So I'm going to write 1 and 5 over 21. Okay. 1, 5, 21. And finally, part D. We get to borrow, maybe. No, maybe we won't need to. Let's find out. This is a subtraction problem. 1 and 11/15 minus 1 and 2/5. Just like we did for a previous problem with adding, let's change this to have a common denominator of 15. So just like just like for part B, let's do 5 times 3 is 15, 2 times 3 is 6. So it's 1 and 6/15 for the second fraction. Okay, so now we're doing 1 and 11/15 minus 1 and 6/15. Actually, we don't need to borrow here because 11 minus 6, we can just subtract right away. 11 minus 6 is 5. So I'm getting 5/15. 1 minus 1 is 0. Now, we don't need to write that in our final answer, 0 and 5/15. So we really don't need to write it in your final answer there. But let's see, 0 and 5/15. It's really just going to be 5/15. Except we can reduce this. So if I type in 5/15, it's not going to accept it because I can reduce. So 5/15 is going to give me that same error message that we saw, although your answer is equal to the correct answer, blah, blah, blah. So let's reduce it. We can reduce it by 5. 5 divided by 5 becomes 1, and 15 divided by 5 is 3. So our final answer is 1/3, or 1/3 for that one. Okay, good. So I'm going to wrap this up now. You've gotten quite a whirlwind review of fraction operations in this first lesson. And we're going to continue using fractions throughout the course. So keep practicing. Please ask questions if there's part of any of these videos that you're not understanding. I'd be happy to, I know you can't ask me while you're watching or recording, but you can write down your question or send an email right then, send a screenshot, send a picture of your work. I want to hear from you if you're stuck, and we can get things figured out. Okay, that's all for now, and I'll see you soon for lesson 2. Thank you.